Okay, so I just stumbled upon this crazy tool called Elf Injector that can literally inject code into Elf executables.
Wait, what? You're telling me it basically modifies existing executables on the fly? That's wild.
Exactly. It uses this relocatable code chunk that runs before the original entry point of the executable.
And it only works with 32-bit ARM processors, right? What does that mean exactly for how it operates?
Yeah, that means it's limited to a specific architecture, but the cool part is the mix of C and assembly it employs.
It's like having a Swiss Army knife for code, where you can insert specific tasks into an existing program.
Right, and it includes actual command line tools that make this process quite user-friendly.
What's the most mind-blowing feature of this tool? Is there something that really stands out?
Totally. One of the chunks it injects can output command line arguments and even the environment.
No way, that's like giving a program superpowers to introspect itself at runtime. What happens next?
The injected chunks have an array called inject info that transmits all this data to the injected code.
So it essentially lets the new code know everything about its environment, including where to execute from.
Exactly, that injecto can hold values like type, length, and entry offset for the chunk.
I can't believe how deep this goes. It's almost like programming within a program.
Yes, and the way it handles memory, like ensuring it maintains a position-independent code, is fascinating.
Does that mean no absolute addresses are used? How does that work without breaking everything?
Spot on. It relies on the program counter for address references to enable this agility in memory.
Genius. You can literally move it around in memory without any issues.
Right? Plus, they make use of something called a thunk that acts like a placeholder for execution.
Whoa, so a thunk facilitates the jump from the original code to the new injected code seamlessly.
Exactly. It's all about keeping that seamless transition without the main program ever knowing.
That's like stealth mode for executables. What kinds of applications can we see this in?
Great question. Security and debugging tools often leverage this kind of injection for testing.
Oh wow, that's a game changer for how we think about code safety and verification.
And because it minimizes reliance on external libraries, it can operate in really constrained environments.
You mean it can work in places where memory and processing power are limited? That's brilliant.
Absolutely. It's what makes it a perfect candidate for embedded systems or IoT devices.
So much potential. What about the creation of these chunks? It's not just plug and play, is it?
Not at all. You have to ensure no absolute addressing is utilized and handle system calls directly.
That sounds intricate, but once you get the hang of it, it's like crafting spells for the digital realm.
Exactly. It's like you're building your toolkit for not just modifying, but augmenting execution.
I can see how exciting this would be for a developer. Do you think it could backfire if misused?
Definitely. The potential for malicious uses is certainly there, just like any powerful tool.
It's that age-old dilemma, isn't it? Power can be used for both good and bad.
Exactly. But understanding how it works is the first step in ensuring responsible use.
I love how this opens up not just opportunities, but a discussion on ethics in coding.
Totally. It's a technology that's as fascinating as it is powerful, right?
I'm blown away. It completely changes how we perceive the limits of software.
Right? We're not just users anymore. We're architects of the executable universe.
So, what's next? Should we dive into building our own chunks?
Absolutely. Imagine crafting something that could redefine how programs run.
Let's get to it then. The world of coding just leveled up.
For sure. Ready to compute outside the box.